Welcome everyone. In this video lecture, we will solve a GATE 2019 EC question in which we have to find the reverse bias voltage using diode equation. So basically, we will use diode equation to find out the reverse bias voltage. So the question is, in an ideal PN junction with a ideality factor 1 at 300 Kelvin, the magnitude of reverse bias voltage required to reach 75% of its reverse saturation current. Okay, so in the question we have to find the magnitude. Okay, the magnitude of a reverse bias voltage. Say this one is our nothing but simply VD. That one is your minus VD. So to tackle this type of question, so it is somehow related to diode equation. Okay, to tackle this type of question, first try to make a PN junction diode characteristics. Okay, so I'm just making the diode equation ID in milliampere, and I am just writing VD in volt, and better to write the diode equation ID equals to Is e to the power Vd by eta Vt minus 1. This one is a diode equation, or sometimes say the Shockley diode equation, where in the question it is given eta is 1, that is our ideality factor is 1, and these are some value. Boltzmann constant 1.38 into 10 to the minus 23 joule per Kelvin, Planck's constant 6.6 into 10 to the minus 34 joule per second, and charge 1.6 into 10 to the minus 19 coulomb. So as we know the diode characteristics, so I'm just plotting. Okay, so this one is more or less some diode characteristics. Okay, go sharper. Okay, this one is a diode characteristics, and this one is our forward biased, and this side should be our reverse bias. Reverse. So if we know this one, so here we can observe that this point is more or less our minus Is reverse saturation current, and this can be our some more or less the diode current in the reverse bias. Okay, and in the question it is given required to reach 75% of the 75% of its reverse saturation current. What it means, so that we have to think 75% of its reverse saturation, we have to find the reverse bias voltage required to reach 75% of its reverse saturation current. So this point is Is ID equals to minus Is, and this point is in the middle. We can say the ID value is minus Is by 2, means 50% of the ID current is a, say this one is a 50% of Is. Okay, and below that, just I am just picking some different color. This point, one can write this ID as a minus 3 by 4 times of Is. So 75% means 3 by 4 times of Is. So in this case, the ID value will be minus 3 by 4 of Is. That you have to identify. Means required to reach 75% of the reverse saturation current. So this one is the reverse saturation current. Okay, I'm just highlighting. This one is our reverse saturation current, and then after in the middle it should be this one. Okay, so in between there should be 75%. Okay, 75%, so means 3 by 4, simple 3 by 4. Okay, so this will in the middle, say this will be our ID value. This one is basically the diode current in the reverse bias. Okay, so in that time where it is at this point, what should be this voltage? Okay, so its value will be say minus Vd, so that we have to find. So what we have to write now, we have everything. So ID value will be our what? minus 3 by 4 times of is 75% of the reverse saturation current. Then write is e to the power vd we have to find, so no need to worry. Then eta will be 1, so minus 1. So this is will be cancelled out. So one can write 1 minus 3 by 4 equals to e to the power vt by vt, or one can write this as a 1 by 4, 1 by 4, or simply write 0.25 e to the power vd by vt. So now we have to solve this one. So what we can write, by taking the ln on both sides, ln e base 0.25, then ln e base e to the power, then it should be simply vd by vt. So we have to find this vd, so vd will be negative value. Okay, so from that point we can find vd equals to vt times ln e to the power 0.25. So vt is 26 millivolt thermal voltage into ln e to the power 0.25. So if we find the value of this one in your calculator, it will come 1 minus 1.386. And if we multiply with this value, it will give some value, negative value, and minus 36.04 millivolt, which is nearly 36 with negative sign, because this is reverse part. So this one is the thing. So it will come minus 36 millivolt. So our answer will be 36 millivolt, because we have to write in terms of magnitude. So we are not writing the negative part. So very simple. Once again, I am just, if this type of question will come, first write the diode equation. Okay. After writing the diode equation, what is given? ID is given, and it is given with 75% of its reverse saturation current. We have to find the value of VD. At this point, we have to find the value of VD. It may be negative. Okay, so it will automatically come. So ID, the this vertical axis is ID. So this one is the saturation current. Is ID equals to minus Is, the negative. So in the middle, it should be minus Is by 2, and the 75% of Is, that is our minus 3 by 4 of Is time. So this will act as a our ID value. Okay, so that's why I'm writing this as a ID. So this one is the ID value, and after putting everything, we will get this expression, and finally VD value will be VT ln, okay, ln 2.2 0.25 minus, and after calculation we are getting minus 36.04 millivolt. So the correct answer will be like this, 36 millivolt. So this very simple one, but you have to know the diode characteristics, you have to write it, and we have to use the given data. So there is no need of Boltzmann constant here, Planck constant Q. Directly we can find. So our correct answer is 36 millivolt for this question. So thank you for watching this video.